Hi, it's Mrs. Scarple, and in this video we are going to look at finding missing side lengths of triangles without using any trigonometry. So here we have a picture of a triangular shaped park overlaid with a coordinate grid. What would we need to know to find the distance around this park? Well, we'd need to know the distance of every single side. And since we have this coordinate plane, we can definitely count two of the sides. So this is starting at 10 and going to 80, so that's a distance of 70 yards. And we're at 10 and we go up to 50, so this is 40 yards. But how are we going to find the distance of this side of the park? Well, if we have a ruler, which I just so happen to have, and this ruler has markings that it's matching up to the grid pretty well. It looks like for every 10 millimeters we've got the grid. So I'm going to measure, so it's going to match our yardage, so 10, 20, 30, 40, 50, 60, 70. I'm going to lay my ruler from grid point to grid point and measure. And this is going to be approximately 78 yards, I believe. That's 75, 1, 2, I believe we can say 78 yards. Since that's 78 yards, when I measured it out, I should be able to add 40 plus 70 plus 78 for a total of 110, 188 yards. But what if I don't have a ruler handy? What if I don't know what the scale is going to be? How can we find the sides of a right triangle then? So let's draw a right triangle here. Here's my right angle, and we know from working with our trigonometry that across from the right angle is our hypotenuse. Now we're going to be using what's called the Pythagorean Theorem to solve for missing sides of right triangles. Now we use this when we know two of the sides. The hypotenuse is always side C. The two sides that form the right angle are sides A and B. It doesn't matter which side is A, which side is B. Those are your sides A and B. So the Pythagorean theorem says when you have a right triangle that the length of A squared plus the length of B squared is going to equal the length of C squared. And as a reminder, C is always the hypotenuse. Always the hypotenuse. So let's put this to practice. Again, I have a triangle that's on a grid, so I can find the length of two of the sides just by counting. 1, 2, 3, 4, 5 units for the vertical, 3 units for the horizontal. I'm going to call my 5 units side A, my 3 units side B, and we're going to be looking for side C because it is my hypotenuse. So A squared plus B squared must equal c squared. So we have 5 squared plus 3 squared must equal c squared. So we have 25, that's 5 times 5, plus 9, that's 3 times 3, is c squared. And when I add the two together, I have 34 equals c squared. But I'm not looking for c squared, I'm just looking for c. So what I need to do is find the square root of 34. Now, if I want the exact answer is the square root of 34. If I want an approximate answer, well then I need to take my calculator and I need to, with this particular calculator, I type 34 and then my square root button. And it is approximately 5.8. when I round to 1 decimal place. On the yellow calculators that we use in class, you would press the blue button, the x squared button, and then 34. Here we have a right triangle, and we're already given the sides. So let's start by identifying which side is C. It's always the hypotenuse. And then we have A and B as the legs is what they are called, the sides that form the right angle. So we have 12 squared plus 5 squared equals C squared for 144 plus 25 equals C squared. Add the two together is a total of 169 equals C squared, and again you need to take the square root of each side, and the square root of 169 is 13. 13 times 13 is 169. Now, Pythagorean theorem isn't only used when we need to find C. We can also use it when we need to find A or B. So 14 is the hypotenuse, that's C. So in this case we have 7 squared plus x squared equals 14 squared. So that's 49 plus x squared equals 196. But I need to get x squared by itself before I can take the square root of anything. So I need to subtract 49 from each side. That leaves me x squared equals, and just because I want to verify my math, 196 minus 49 is 147. And then I'm going to take the square root of 147. So again, the exact answer is the square root of 147. The approximate answer is 12.1. We can also use this with application. It's not just doing this with any triangle that we're given sides. So in this problem we have two skyscrapers that have a skywalk connecting them. So you can walk between buildings without having to go down to the ground and walk over. And we need to find the length of each support beam. Well, each support beam is across from the right angle. So each support beam would be C. They're also pointing out that each segment of the skywalk up here is 23.26. So this is split in half. The support beams meet in the middle at 23.26, and we're given the height of 47.57. So we have A, we have B, and we're looking for C. So we can set this up as 47.57 squared plus 23.26 squared equals x squared. Now these are numbers that we would most likely need a calculator for. 47.57 squared, and I'm going to go ahead and round this. So we have 2,262.9 added to 23.26 squared, approximately 541.0, and I'm including the 0 to show that I did round it to one decimal place, equals x squared, or actually because I rounded, I'm not going to say equals, I'm going to say approximately x squared. So 2262.9 added to 541.0 is 2,803.9 for our approximation for x squared. Now, to finish the problem, to find just the value of x, we need to take the square root of each side, and that leaves us with approximately 53.0 meters. The 5 would cause the 9 to round up, but 9 rounds up to 10, causing the 52 to round up to 53. And that is how we use the Pythagorean theorem to solve for the missing side when we know two sides.